Hi everyone, welcome back. So this time we're working on a slightly different problem. It asks us to find the center of mass. So, what do you think you do? Do we need to find those reaction forces to figure this out? Do we need to find out, is the density important? Is that it's 0.3 meters thick important? I'm not going to tell you. So what I'm going to do is I'm going to let you have some time to yourself to try out the problem. So I'm going to count to 3. You take a few minutes to do it. And when we finish, come on back and see how you did. So, 3, 2, 1, and we're going. Okay, first off, we got to decide vertical or horizontal strip. In this case, we're going to do a vertical strip. I tend to default to vertical, but it just depends on the problem. The reason for that is because at least one of these is just in terms of x. Now, that would have been easy to switch either way, but you can do what you want. It's not all that terribly difficult. The second reason we want to do that is because we can hit both of these at the same time. If we're doing it in just horizontal strips, we're going to have to do one and then the other. So we can do this in just one step. Okay, so first off, we got to get our area element. Since we're doing a vertical strip, the base is simply dx. And the height is going to be y2 minus y1, which is going to be the square root of 2x minus x. Sorry, minus negative x. Goodness. So square root of 2x plus x. So this is our area element. Now, what's x squiggly hat? Well, since it's a vertical element, x squiggly hat is just x. If it's a horizontal element, then y squiggly hat is just y, depending on which one you use. What is our y bar? Well, that's going to be halfway between y2 and y1, so that's the average. So we just take y1 plus y2 and divide by 2. So square root of 2x minus x over 2. We keep on going. Integral looks crazy. It's not too terribly difficult. Remember, square root of 2x is simply 2x to the 1/2 power. It makes it a lot easier when you're doing integration that way. And what we have here is you see, okay, this is dA. This is x squiggly hat. This is the height. This is the base. And then we have d on the bottom. This is the height. This is the base of that rectangle. We integrate from 0 to 2. And we solve. We get 1.257 meters. Okay, we've done it. It's beautiful. Now let's find our y bar. Y bar very similar, except for y, it's not quite so nice. And so we're going to have the square root of 2 minus x over 2. That's the y bar. So we have square root of 2x plus x right here. We multiply everything out. We do our integration, and we'll get 0.143 meters. So there's lots of integrals here. We're finally at integration. You're like, oh, I thought we could escape that. Yeah, eventually you have to use those integrals. So be very careful with how you set up your element, because if you do it wrong, you're going to make it a lot harder on yourself. Now the question I want to ask you right now is, what about the whole, density and thickness? Is that important? I mean, no, honestly it's not. Center of mass would be the same exact place because it's got a continuous constant density. So everything else we're doing right here is actually necessary to find the center of mass. And this right here, having found the centroid, is actually the center of mass because it's a homogeneous object. Let's go ahead and use this to help us calculate those reaction forces, because that's just going to be a little bit more extra details that'll help us. Don't forget, because it's homogeneous, the centroid and center mass and center of gravity all same point. Okay, so now we got to place the weight of the plate at that centroid G, because it is our center of gravity, it's in mass. We know what our area is by doing an integral. We can also then figure out what our weight is by taking our integral for the area, multiplying it by the width, and then multiplying our density, and finally by gravity. So this one right here is the density, and this right here is the volume. Density times volume gives me mass. Mass times gravity is equal to weight. So I get 107.8 kilonewtons. So I have that acting right here, and I can figure out my reaction forces because I've got 3 equations, 3 unknowns, and I can solve. So I might take some of the moments around point A, which will help me figure out what NB is. And luckily for me, that's a nice straight line, and that is perpendicular, so it makes it a lot easier on me when I'm trying to calculate moments. and so the forces in the x and y direction to solve the rest. There will be both an x and y component because this has both an x and y component. If you look at this, one equation, one unknown every single time. So if you set it up nicely, you can solve. Once again, none of this was necessary to solve for the center of gravity or the center of mass because this is a homogeneous material. External forces don't affect where the centroid is unless they are like crazily deforming the body. Then it's not this class. Statics, we don't deform things. Okay, so with that, I hope this helps you. I hope it's beginning to start to click how this works. If you have any questions, please feel free to email me. See you all next time. Bye-bye.